Hey Zach,
Hey Kevin, how's it going?
pretty good. I'm gonna leave my camera off for a minute. I'm eating.
No worries. I managed to barely finish my food before we started this. Oh. No, I'll actually be going from this to work unironically on a Sunday, so that'll be fun.
Oh wow.
Yeah, I've got some stuff I want to do before Q4,
Hmm.
or before Q4 finishes. We've got a interesting new pipeline parallelism thing for Accelerate that the Torch people have been working on.
Gotcha.
Because
Is Q4 for you guys end of December?
yeah,
Gotcha.
like I think I have my meeting with my boss like next week, but still want to get it done before vacation. So,
Yeah, makes sense.
hey, Manic, welcome.
Hey, Zachary, thanks.
Oh,
Hey,
wait,
Kevin.
I don't know, another
Hey man.
minute, maybe. See if the other usual folks wind up coming.
Cool.
Um, but what do you guys think of this week's section?
Yeah, I think it's important. Exceptions are obviously the important part of a programmer's guide, and most people kind of like do not give proper focus to this of how this can be done, the various factors that can be taken into account in a good exception handling system. So I was thinking about that.
Mhm. Yeah, that's fair. That's something I've tried to implement with Accelerate that I might get into a bit later in more detail. It's good in practice as long as your users actually read the exceptions. Um,
Hmm.
More often than not, they don't. Because like I'll show examples later, but it got to a point with a few specific errors in Accelerate where I knew exactly what was wrong, with the user code, and exactly what they needed to do to fix it because there was nothing we could do. All they did was copy paste a stack trace, post in GitHub, and go, "What's wrong?" Well, read it. It tells you the error. Um, so I know it's a good idea, but I'll show sort of like practically why that's good, but the user will still always be dumber than you would really like them to be. The video of who posted that? I can't remember her name, but it was a like TikTok like video where it was how user feedback generally goes, and the directions were now put the circle in the circle box, and users would put it in the square box because that's what they could fit it in. Sort of that situation where it's like, we have directions, but that's okay. All right, looks like it might be us three, so let's just walk through the chapter. And then I'll make it a bit short because I don't think I have too many notes for chapter 11, so it might not take as long. But if we go down tangents, we go down tangents. So chapter 10 talked about, exception handling and how you completely try and eliminate exceptions as much as possible, be that either fully eliminate it by pulling complexity downward, or by, if you can't, give users more explicit exceptions when you absolutely have to. It also then mentioned about how, that being said, exceptions generally come up in these niche cases where you as a developer didn't necessarily expect a user to behave a particular way. And so you can come into this push and pull of trying to define every error out of existence. And so you have like 16 different if statements, depending on what the user passed in to raise a particular error for it. And that doesn't actually really make sense when you think of scalability. it makes sense from making sure users can't break their systems, but there's always going to be another case. There's always going to be another oh, thanks, Kevin. There's always going to be another set of weird things that a user tries to do, weird combination of inputs. And so the best way that you can deal with that is try and generalize it as much as possible and minimize the actual needed exceptions to get there. And so it talks about defining errors out of existence using like Java substrings. So you can adjust like the inputs to avoid this particular exception. Another part it talked about was masking exceptions. And masking exceptions is this whole idea of, okay, well, a user put an input wrong, right? Let's say they put in an integer when it should have been a string that we're trying to parse. Well, we could just raise an error about that, right? Or we can try and parse that string or parse that integer into a string. And if that string matches what we want, then don't raise an error. Yes, the user is technically using the API wrong, but it's a case where even though they're still using it in this way, and we can pass it along without breaking the system. Then you have like a whole differentiation of, well, if you're going to do that, then you probably should upstream the type changes and, specify that it can be one or the other. But it's one way that you can sort of mask them and hide these exceptions to sort of figure out what the user was trying to do without having to fully break what they're doing. And then another part of sorry, what's up, Kevin?
I was just gonna say, in those cases, should you tell the user that you're doing that?
Yeah, I'd usually do it as like a log, like
Yeah.
a warning.
Okay.
Yeah, because it is unexpected. And so the two branches you have are change your documentation to just strictly support the casting, or raise a warning for the user instead.
Right. Yeah, I feel like, I think that makes sense. Just like don't unexpectedly fail, but or like don't unexpectedly change things that the user put in, but also it's probably what they want, and if it's not, then they'll rerun your code to be what you want. If they know, like if they know what they did was not technically what you were expecting.
Exactly. Like this is what we do in accelerate launch, like our CLI command. Because before, if you weren't specifying certain arguments, then the whole system would break and it wouldn't launch anything, because we were requiring the user know, like, how many GPUs do you want to run this on? Are you wanting to run on multiple GPUs? Are you trying to run on single GPUs? And when I rewrote the API, I instead worked on basically figuring out, based on the environment, how we can determine like how many GPUs are available. If there's multiple GPUs, then you probably want to run on multi-GPU. And so now we aggregate all of these warnings and exceptions and new defaults that Accelerate will set. And then after you launch, it just goes, hey, you didn't pass anything, you didn't configure anything, but this is what we think you want. If you want to change that, here's how you pass things in.
Right. Yeah, that makes sense too.
Yeah, and so like, you don't have to crash a system, but tell the user how to like set the variables.
It's like give them defaults, but also tell them, here's how you change the defaults.
Yeah.
If you don't want these.
Yeah, and then if you are okay with having this annoying message, then that's fine. If not, here's how you get rid of it. And that's not something where like we're planning on deprecating anything or nothing like that. It's strictly always going to be there, because the goal with this isn't, oh, I should change the API from the ground up to support the thing. You just warn the user that we're handling it and let them know that it's not silent. And then it talks about taking it too far, where Defining away or masking exceptions only makes sense if the exception information isn't needed outside of the module. Important things must be exposed, but unnecessary details should be hidden. So a good example of this is, I believe it was Kara's 2. I know Kara's 3 just came out, but I think Kara's 2 is when Cholette mentioned that he completely rewrote their exception handling system to give custom feedback based on what you passed in. So like if there was a type mismatch, then it would actually give detailed information about what went wrong, but not give under abstracted information. So like a good example of this is, say you're training on PyTorch and you get a device mismatch error because the linear layer on the last layer of the model was on CPU and the input was on GPU. You get this mildly cryptic error message that says like, A and B are on different devices. That should not be the case. Switch them. And that can be cryptic as hell. If I got to be honest, I don't like it. And so one thing I did for at least like my own Accelerate FastAI submodules when I wrote FastAI debug is I just switched that error message to just tell the user, this is on this device. This tensor B is on this device. You got an issue. Make them on the same device. Because that's all you need to say. You don't need to say this linear layer was on this device and this one wasn't. Because a beginner will just go, well, why is only some of my model on the GPU? I thought the whole thing was. Just say the whole model was. Don't give them more details than needed. And then the last part I talked about is special cases make code harder to debug and understand and increases the likelihood of the bugs. So if you know that fighting exceptions in users breaking your code is an uphill battle, especially because with Python, how you generally write things, it is a don't ask permission, ask for forgiveness type of language. If I'm remembering this right, because permission would be based on types. So yes. And so because it's sort of this ask for forgiveness, run it first and then see if things break. If you keep exponentially adding special codes to block users from doing certain things, just use a typed language. Use a different language that gives you that limitation that you need, because there are better ones for that besides Python.
I have a question on, I guess, special cases that you add.
Sure.
Do you think that you should have a special test condition for every exception that you expect to potentially be raised?
Yes. If you have an exception in there that you are specifically making a special case for, it needs to be a test.
Okay.
We do this often in transformers whenever I see if like I see a user finds an edge case, a special exception where we need to allow it. To quite literally that exact bug, I throw in as my test.
Yeah, I like that a lot. I think it makes your code just like way more resilient if you add those in, because then if it doesn't fail, it's like, okay, like what did I screw up here that this is no longer raising? Exactly.
Like, oh no, we fixed a like backwards compatibility bug or something, and now it's broken. Welcome, Al. We are just now going through the notes on chapter 11. So quite literally just starting that.
Okay, cool.
Yeah. So chapter 11 talked about, and I sort of hinted at this last week, the design it twice mindset. And sort of this importance of, more likely than not, the first way you build something isn't going to be the best way. It's going to be the easiest way for you because you're the most familiar with the API, but it's not necessarily going to be the best way. So it talks about considering radical different approaches. So by doing so, you gain deeper understanding of how each of these different functionalities work and these API designs work. Like, and this is more than, oh, I need to build something from the ground up. It can just be wrapping around something. When Kevin joined, I was mentioning that as part of work right now, we're currently working on a library that PyTorch has, where we can do basically pipeline parallelism using accelerates device map equals auto. And the key with that is, so TLDR, this is what helps you find the split points. And this is some of their API and how you do it. And then you have this whole output equals stage thing. And so now what I'm trying to think about is, okay, we want to make this into accelerate to where, users can do like accelerate.prepare, or not have to deal with making this pipeline stage, making this pipe, figuring out, these split points, and what's the best API to do it. So quite literally after this meeting today, I'm going to go work on that. But I'm probably going to design 2 or 3 different interfaces for it. One that probably resembles Trainer, one that resembles just the low-level API that Accelerate already has for like big model inference, and then probably one that uses the accelerator instead. And I'm going to basically look at all of these and go, hey, which one makes sense for us to wrap around from a user perspective? Because at the end, you just want an API design that's easy for users, that follows most of the philosophy of what you've already done, right? Because every time you add a new feature, some form of that philosophy might change depending on how the API looks. And so it's important to sort of take that into account and really think about, well, okay, what are a few different ways that I can design this? And most importantly, with this design, what are the friction points? And that just takes practice doing. And it's really easy to just trust your gut on the first design. And most of the time that will work. But especially as like you've been doing this for years and years and years. Sometimes though, I'll still, do exactly like I said. If it's something radically different where I have to completely change how I think about this API, then I'll sit there and knowledge limit myself to A, B, or C and try and come up with, well, what would this look like? How would this integration wind up looking like 5 years from now, or even 5 months from now, if something changes, the users want to do something custom, I want to take it further. And so this sort of are different ways to think about radically different approaches, because it's good to do. It's hard to do because we're very biased in wanting to do what we already know. And it's hard to just magically come up with hey, here's a new situation that I think I could write this with.
How do you do that in practice? Do you actually have like multiple branches from the same commit point and like implement on one branch, then go to the other branch, implement something else?
That's far too complicated. I just do it all in the same branch.
Just like 2 functions that are the same, like maybe have like a _1, _2 or something.
Yeah, or like I'll split them into files, but I won't split them into branches because quick iteration is needed, and I need to be able to compare all of them, sometimes at once if I want to run like a speed benchmark.
Yeah.
But yeah, generally I'll write like, because right now this is part of a custom repo I have, which if you guys are interested in it, I can share it. It's not fully public yet, but it's a public repo. But like right now, it's split up between models, and then like there's an accelerate baseline just using big model inference, and then there are Pippy, and then Pippy accelerate. And so here I'll probably make 2 more files that are my different integrations and how they're wrapped. And then run them, compare everything, and see which one I feel like is the best. It's kind of, I think, what the approach I'm going to do is. Is it the most efficient? We'll see. But it's probably how I'm going to go about doing that for this. So when it talks about like, how do you tell which interface is the best, which way have you written it is good, it mentions that the most important consideration is how easy it is to use. Right? And that's the case always. Which one is the easiest for your downstream user to wind up working with? Because it can be a low-level API. If it's an easy to work with low-level API that's simple to set up and simple to use, then that's okay. But if there's a better alternative where you can abstract a few things and create a better interface that limits what the user needs to know from a knowledge level, even better. And so as a result, like when it brings ideas of how do you compare these different alternatives, check which one has a simpler interface or is more generalizable, and then also determine if one is a more efficient implementation than the other. So efficient means more than just lines of code. Is it easier to maintain? Is it easier for you to show growth with and improve upon? Hackability, speed. There's a few different ideas you can use when determining whether something is truly better or not. And it just depends on what makes sense for the situation, right? Like if I'm going to write an API that a user might never touch, we're just changing the back end of something, then I just care about scalability on our end and maintainability. I don't particularly care about the other parts. And then it mentions another idea of combining features for a better design. It could be, one of the alternatives, or as you're exploring one of your alternatives, you realize that you can take ideas from each of them and combine it into something better. Or you could just sit there, play with it for a week and realize all of it's garbage. And if that's the case, that's okay. That just means you have a hard problem. And so what you do from that is look at the problems that each of them are facing and use that problem to help you further how you're building the API, right? Like there's certain problems with this minimal Pippy integration that I currently have, where my coworker showed me how he integrated Llama and what he had to do. And when I saw what he had to do, I was like, this is very different from my code. What all did you have to do here? And so I'm going to look at that and, based on how he struggled with it and what I thought could be expected, where can the implementation be simplified and where can we build off of each other's thinking to come up with a stronger interface, because he thought of something I couldn't, and now we have two different cases that we can check for. And the other thing that people tend to worry about with the whole design it twice is, oh God, now I need double the time to think about it. Not really, because you're already thinking about it. You've been thinking about it. And in your head, you've kind of been thinking of, well, how can I design it? And so it really doesn't take that long. The book mentions for smaller modules like a class, maybe an hour or two. For me, it tends to be minutes, just because I've been working with certain libraries for very long. And so I can immediately visualize, think, and program exactly how that needs to be done for smaller things. Mm-hmm.
The alternative to doing something like this, where you design it multiple times, is design it once, have it be a not a great solution, and probably increase your technical debt. It's I guess it feels like the alternative is you get a clunkier and clunkier code base until you're trying to design something and you have to go back and do a bunch of refactor instead.
Yes, you're literally addressing technical debt early by doing this, because you can find those cases where later on, some of them at least, where you're like,
yeah,
crap, that doesn't work. You can,
which kind of goes back to like chapter 4 or whenever it was, when he showed the chart of if you design things well up front, then you have to pay, you have less to pay back later on.
Exactly. And is an hour or two of your time worth 60 hours trying to debug a thing for a week later? Yes, absolutely. So definitely start practicing this if you can. As I sort of mentioned last week, it's weird to get your mindset into, I thought, a week long on this beautiful API and I know exactly what it's going to do. And now I have to spend more time designing another one. I typically don't go through the full implementation when I do these. I think about the full implementation in my head, and then I don't code it. Because usually that's enough for me to visualize, okay, well, API A is going to operate like this, API B is going to operate like this, maybe write it down in some flowcharts. But based on that, you can generally get a good enough sense of, well, how's this going to feel? How's this going to look? And then if they're too close, or I'm like, I don't really know, then I'll go through and code both of them. But usually just spending a few minutes truly considering, well, how many different ways can I write this? Which user interface makes sense to me? Bring a complete stranger in and go like, hey, given these, which looks more easy to you? Trust them, they're the idiots in terms of technical knowledge of your library because they know nothing, right? That's the point. Rubber ducky, except it talks back to you. And so, based on those, then move forward. And if, you like some of the interiors about option A that they didn't do, you just showed them the outside interface. You can do whatever you want inside for the implementation. And that's sort of practically how I tend to go about this. It's not perfect, but it works most of the time. There's some cases where like it's just so difficult and there's nothing really pretty I can do that I just wind up getting into discussions with my coworkers for like 2 weeks. And that's just what happens. And then you eventually come to a conclusion of, okay, this is maybe what we can do instead. And it might be a completely different answer than what you thought. The biggest example, I guess, for this was, and I've sort of mentioned this before, when I was designing the gradient accumulation interface for Accelerate, the goal with Accelerate is nothing can be magical, right? No magic can exist. Every error at least has to make sense to the user. Nothing can just be like weird meta classes. It all has to make sense. And when you're doing gradient accumulation on distributed data parallelism, you have to worry about how often your GPUs talk to each other, because that winds up being a time sink. And there's an implementation in PyTorch that lets you avoid that until the backward pass when you've done accumulating your gradients. And I showed, my initial design to Sylvan, and I was like, hey, look, I did this thing. I feel like it's great. Can we use it? Because it was just one line of code and it did its thing. And Sylvan immediately axed it and went, no, too much magic, design again. And we went through like 4 or 5 different integrations and implementations of this before I used the same user-facing API, but I designed another lower level API below it to expose to the user as well as an alternative to remove that magic. Under the hood, it was still the exact same. It was the exact same code, exact same outer implementation, but we exposed more of it as a different API. And, without having that outside information of this is still too magical, there's, at the time, no way I would have thought, oh, I don't need to do that per se, just let us handle it. And so it's cases like that where even if you don't necessarily think about designing it twice, when you get feedback from other people, that also counts as designing it twice, I believe, personally.
Is that why code reviews are like, I'm assuming you recommend code reviews for any new feature?
Yeah.
Any bug fix?
Yeah, because like code review in general, always needed, period. Like nothing gets pushed to main in any Hugging Face repo without getting a pull review, period. Unless it's like a critical bug fix that, you're being very vocal about, the fix exists, yada, yada, it just doesn't happen. And one thing that sort of dawned on me, it was a few months ago, it was a tweet, and I forget who it was, but they were maybe an engineer at Microsoft or something. And they basically said, now, what do you think code review is meant for? And it was a poll. And is it communication, bug fixing, or high level review and, discrete gutting through code. And of course, everyone said 3, right? Because generally we know that pull request reviews are meant to be that. No, that's not what it's meant to be. Pull request is mostly a communication of, hey, we're doing this thing. I want to bring it in. And I've worked on it as best I can. When you get into more experienced workplaces, generally you'll just see check marks for things. Because, say I have a backlog of 40 issues I'm looking through. I can only have 5 minutes to look at your PR. Right? And so what I'm going to look for is, A, does the interface look nice? B, anything weird that smells awkward or something that could be improved upon? And C, does your feature make sense? That's my review. My first review, right? And then later on, I'll like look in the nitty gritty a bit more and go like, hey, maybe this isn't the most optimized choice, but you're generally not there to like rip into people's code and question everything. It's meant to just be a communication and try different ideas. And sometimes it might not even be that. And so when you're coming up with a better, or trying to come up with ways that could be better designs, one thing I like to do in my pull request reviews nowadays is I'll just mention, here's my first draft of the API. I think it works good enough. Let me know what you guys think, if you have some time. And then based on their feedback, then I might go through and review it again, and sort of check that, hey, all right, philosophy-wise, does it make sense? Implementation-wise, does this make sense? And then I'll go add the tests, because you're not going to get that generally from your reviewer. And when I sort of thought about it this way, things made a lot more sense, right? Because the hand of God, if we call like, the main person that's going to hit merge, they just want to make sure all the tests pass and things make sense. And then they're just going to hit merge for the most part. As quotas scale, as issues scale, it's a bit unrealistic to expect every major maintainer to pull down your code and run your code and think about your code one-on-one, because they're not going to have time for that. They generally trust you for it. And so if you think of it more as just an enabling review process where they can sit there and you can get a different perspective of, maybe this doesn't smell right, can you come up with a different way? Then we're coming back to this designing different ideas, right? Because they're giving their perspective on how you could code it. And even if you couldn't see that, they're telling you, and you can now go write it. And then you can get back to them and go, well, okay, I tried your way. While it simplified the code, it didn't simplify the interface. So I think this is still the best way. And so it's a way to merge the two together where you can enable your teammates more because they're spending less time reviewing your code, right? Because they're not expected to sit there and run it. And then you get the benefit of getting their ideas as alternatives if you couldn't think of any to go run with. And this isn't like guaranteed silver bullet, right? Because they could just review and give you a green check mark and be on your way. I've had a few of those where I'm like, I was hoping you could give me a different idea, but that's okay.
Yeah, looks good to me.
Looks good to me. Great, let's ship it.
Like, this was the first draft. I don't have any tests.
Why is suddenly all of Maine failing? Oh God.
Yeah, that I feel like that makes a lot of sense. I always think of, I don't know, I've always thought of pull requests as kind of a way to like cross train or like get multiple people looking at the same code so that like if you get hit by a bus, somebody else knows what's going on with something that you've merged. But I guess probably not really. I mean, not at like a big, like somewhere with a lot of people, at least. That's not really what it's for.
Yeah, I was gonna say, you'd be very surprised. Like, practically when it comes to like Accelerate, and I imagine like the knowledge triangle that we have, it's more like a square at this point because we have a We have Benjamin, who's working on our team now as well. But, if Sora makes a pull request for anything related to fully sharded data parallelism or deep speed, I kind of know what's going on, but I trust him because I don't know a whole lot about deep speed. So I'm aware that this thing got done. I do not necessarily know how it works because I don't necessarily need to. I want to, and I should. I don't have the time investment for it right now, but I should. But as a result, I have to trust him. And that's a team of 4 people. And same with Mark when he does anything with big model inference. And in some ways, it's me whenever I'm designing inner implementations for things that other people can't run.
Yeah, I like the idea of like creating almost like a first draft. Maybe even just like leave the implementation off of it, but like here's the signature and then just have pass underneath. Like this is what it's going to look like. Maybe you need a little bit of the how does it actually work underneath, but like if all you're looking for is feedback on the passing, like put this function into our code base, like that might be enough to just say here's what it's going to do. What don't you like about this idea?
If I do that, which I have done before, I generally will do it on Notion. I won't do it on GitHub because, especially as I've seen in our company, I quite literally get 30 to 60 notifications a day. That is going to get lost. If you have it as a like Google note or a Notion and you DM it to me on Slack, then that's different and doesn't get buried too much. And I do that sometimes. I did that a lot when I was very new at the company. One thing that, as you get more experience in software engineering, though, tends to happen, and what like your managers and whatnot will want to happen, is they will trust what you're doing. You don't have to like check in every 5 minutes of, hey, is this the most optimized way of doing this? Hey, is this good? Is this bad? How is this? Because that's what you're supposed to do. What you present to them is what you came up as the last final solution, and then work on that, right? Some companies have that sort of process where you have to sit there and iterate through it a lot, and that slows everything down a lot more than necessary.
Yeah, I think I feel like that it's the harder the problem, the more like if I've tried a few, when I would do that is if I've tried a few iterations and like nothing really feels quite right, it's like I keep coming to solutions that are like this is not good. Like I've got an example of I've been working on the rules engine of our internal system, and it's like I've probably designed it like I don't know, I probably designed it like 4 different times on my own, like without really like bringing anyone else into it, and it just kept like not working. Like it would, a couple times I designed it and it was like, okay, like the rules side looks good, but now if I try to like process a rule, that side is going to look really, really big and clunky, and it's going to be really hard to add new options and stuff. And like there were a lot of different issues that I ran into. So eventually what I did was I created I did some flow charts of just like, here's what I think. Because actually first what I did was I tried to go to OBS and just like record my thoughts on it. Cause I was like, let me just like talk through this to myself, basically rubber duck it to myself. And when I started trying to like describe my solution, I realized I had I couldn't even like start talking about it. It's like, okay, obviously the current, like what I'm trying to do right now is not what I should be. Like it's not a good solution. So then I went back and was like, all right, let me like diagram this out, put it on a flow chart. And actually it ended up being like 5 different flow charts of like different levels of the system. Like here's what it looks like if you zoom all the way into a rule, and then like zooming out, here's what the overall system looks like. And then finally after that, then I brought in another person on our team that isn't like familiar with the process, but is like a you know, technical mind. So like they had some, you know, that was like the rubber duck that could actually talk back to me. and they were like able to look at it and actually gave me some tips of like like, great, this doesn't look very clean, like what if we do it this other way instead. So I guess I never really got to the GitHub point either there. I used like a diagram, flowchart.io, I think, or diagrams.net as like my, you know, diagram it out, and then pulled in another team member after multiple failures of just like trying to do it without bringing anyone else in.
Yeah, and I think that's like exactly what you should do. That sounds exactly like what I've done before. And instead of a flowchart, right, it was a Google Doc, but it was still the same thing.
Yeah, same concept.
Yeah. You know, the medium doesn't necessarily matter. Like I've had that happen when it was on just a video chat with someone and they were like, hey, I'm designing this thing. Can I like share screen with you for like 5 minutes and let's just give me your raw thoughts on it. And I've had some people share a code base with me. I've had some people share just pictures with me of like how they're designing certain things. The medium doesn't per se matter, I found, as long as you can articulate your idea well enough in however you need to. And honestly, I've kind of found that code tends to be the worst way, because no one ever annotates anything enough. Right, because it's a first draft, you're not going to do that enough per se, because you just want quick iterations. And so it actually makes it a little harder to follow, I found.
Right, you have to figure out what it's like. You have to basically reverse it to pseudocode, or like to, you know, what are these different chunks doing, and then
exactly.
And then you can talk about it. It's like another step of cognitive load.
Yeah. So either, you know, write it down in the notes if possible, or like just walk me through you using the thing rather than just send me the code base. Very good discussion. So in a similar vein, on ending that last point, chapter 12 is a very, what could be seen as heated if you're coming from certain communities. Especially when you consider this book versus Clean Code. And it talks about why should you care about writing comments in your code? And it mentions basically first the importance. So they're critical for developers and sometimes users or power users to understand what your system's doing. And then on top of that, it plays a vital role in abstraction by helping hide complexity, right? You can have complexity in your implementation, but if you annotate it with code, suddenly it's a lot less complex because a reader can know what's going on. And then on top of that, actually writing comments done correctly enhances a system's design. And let me see if my notes, yeah, we'll go into like, what does that mean in a little bit. So it mentions excuses for, you know, why you avoid comments. You know, the biggest one that came from Clean Code is, well, good code is self-documenting. Self-documenting code needs no comments because the implementation itself is self-documenting. I don't have time to write comments. Comments get out of date and become misleading. And everything I've seen in terms of comments are worthless. They're just these weird little things that don't add any value. Why do it? So this book tends to rip a bit into why good code is self-documenting is a fallacy. Good code is essential. Clean code is essential. But a clean, good set of code bases might not have information critically needed about the design just available through the code. Right, like you have the formal interface for a class, which is just a few functions that are being called. But even if these functions have the clearest names possible, and that's the best case scenario, and their doc string generally gives you a good idea, there still are aspects of why you're running this, the situation it's in, if it's an if else statement, why this if else statement exists. It requires comments in it. And on top of that, just reading code to understand method behavior is exceedingly time consuming. Just ask any, senior FastAI person when we go explore FastCore. FastCore is a wonderful library. I love many parts of it, but comments would be a lot more helpful for me to understand things faster, and especially certain areas. And that's not per se critically bad about the library. It is just a quirk with it. And that's quirks with other libraries, because all it adds is just cognitive load when we could add a comment or two, reducing that. As it mentions here, without comments, the only abstraction is the method's declaration. And so if it's just the method's declaration and what it's doing, declaration here would mean like the doc string and the arguments, we could be missing essential information about its implementation. And in case it's unclear, we talked about abstraction earlier as why abstraction can be bad. Here, the abstraction is a good abstraction, the abstraction of knowledge, right? And so a clunkier interface should have a good abstraction of the knowledge documented around it, is sort of the idea that we're talking about right now. So what are the benefits of having comments in your code? Specifically, well-written ones, right? Because just saying one word or two words isn't necessarily a well-written comment, as well as a paragraph isn't a well-written comment, because by the time you read that paragraph, you've lost all sense of where you are in the implementation. So comments should capture information that can't be represented through the code through low-level details to high-level concepts. They reduce cognitive load and address the unknown unknowns problem that we mentioned a few chapters ago. And they help developers make changes more quickly and accurately because they know what's happening, where and why. This doesn't mean like annotate every line of code, of course, but annotate it like you would a paragraph. And then good documentation makes it unnecessary to read the code, serving as a valuable resource for the developer. Now that's a mix, right? Because now we're talking about comments into documentation. I kind of think as like documentation as a whole is three areas: the doc string, the documentation, and comments in the code. Those are all documentation, because when a user is quickly going to find issues, they're either going to question mark, look at the implementation. So there's comments. They're going to do question mark, if we're assuming Jupyter, pull up the doc string, or just go look at the actual documentation. Kevin, did you have a question?
Yeah, I was just gonna say that I think if like where I've seen comments being really distracting is when they do try to put a comment on every line of code, and it's like running for loop, like printing that I'm running the for loop, but like putting a comment on every line that's like not helpful at all. Like I know that from what the code's doing, but like, why are you running this for loop? Put a comment above the for loop that says why you're running it, instead of like, I've seen that on, I don't know. I've seen it particularly with like external, like consultant code. That's where I've seen it. And it's like really hard to get past that.
And that's definitely like what it talks about here. Like comments should have a purpose, and that purpose should not just be redeclaring what the code states below it, right? All of those are what the book would call bad annotations, right? And on top of that, there's a difference between how I will comment like source code versus how I would document an example, because I have examples in my transformers repo where actually I can pull that up real quick and I guess show you. Not trainer zoo. What is it that I want? I can't remember off the top of my head. Minimal trainer zoo. So like in here, I have a bunch of minimal examples of how to use the Hugging Face trainer. And the key with it is all of them are roughly under 100 lines of code, because I wanted something quick and easy. And if you're familiar with Keras, you know that they have something very similar. And so here I have like comments that wouldn't necessarily make sense to have in a code base, right? Like declaring constants. Now this one does make sense because it talks about, you know, why we're doing this. But like load data set followed by a print statement saying downloading data set followed by downloading the data set. That is not useful in an actual code base. It's useful for a tutorial, but it's not useful for a code base. And sort of what Kevin was talking about is the key difference in that, right? Because if it's in a production level system, don't restate what you're doing over and over again. That doesn't make sense. It's already there. It's documented. Unless it's a complex implementation for it, then you don't need to do it, right? Like here's a better one where it talks about creating an efficient collator with dynamically padding, which dynamically pads. Okay, well that tells me data collator with padding does it dynamically, which is nice. That's something that I wouldn't necessarily get, which can be better. You know, it's a balance basically, I guess is what I'm trying to say, right? Like you can have one that exists and you can have a few that, you know, are kind of obvious that explain what's going on, especially if it's an example. But for the love of God, please do not do that in the actual source code. Because
I think even in like that example, I think it would like adding, you know, like numbers to make it more obvious that it's like these are the steps that it's going through. I feel like that would make it easier to follow and differentiate those like step comments from other just normal comments that were in the code as well, even though it's just an example.
Oh, totally. And the reason why you kind of feel that way as well is those were ripped from a bunch of example notebooks that Merve wrote. And so, yeah, each of those that kind of are split up are cells that I
that makes sense. Yeah.
Yeah. And so, like, you know, it makes sense why they're chunked down in that way. And it's a very good observation. I was just lazy, which is fair. But
Yeah,
that would be, yeah, you know, like that makes perfect sense if you like just, okay, write them out like notebook cells, you know, 1, 2, 3. And I think that's what Keras winds up doing for their examples, because they are like, they're text files, but they're also Python files, but they're also notebooks, I think, if I remember correctly. It's some weird thing that Sholette has going on with it that I love. I need to dig into it more. Let me see if I can find it. Keras GitHub. Yeah, so like that is not what I want. Somewhere I have these saved. Examples. Let me see, is this under 100 lines of code? Yeah, so like even in their examples, they don't have any comments. But if I remember correctly, I think that might be because somewhere their examples are like starting to be generated as notebooks. I'll try and see if I can find it later. But clearly that example, not a good example. But I'll see if I can find it later and sort of show like what that can look like, because it combines the idea of like from a Python file perspective, it was over annotated because you had literally paragraphs between each function call. But like as a Jupyter notebook, it makes sense because you're documenting it. And so the general idea there is like, well, for an example, can we really ever say too much? And yes, you can if you like lose all context, I think is sort of where the agreement was for that. But I'll see if I can find that code later and share it. And so then it sort of talked about, well, how do we think about comments from a software design perspective? So good software design can reduce the need for comments in the method bodies. But because comments exist there doesn't necessarily mean that you've built a terrible API. Right? Because comments are different information than code, and they play a fundamental role in defining abstractions. Another way of putting this that I don't have in my notes here, and I believe it mentioned in the chapter, was code is read by computers. Software is read by humans. Work with that. Don't write in code to describe something that can be better explained as a comment stating it in English. Right? Assume a certain level of coding knowledge is needed and then work with that. Like, don't describe this is a for loop or iterating over the data loader, because we know what you're doing there. Is there something happening on the back end that the data loader is doing that we don't know about? Then mention it, but we don't need to know that. And use the comments sort of as a bridge for when things do get complicated. Like, hey, you know, we're iterating through this and magically on the back end, a special sampler got in. Mention that. That way, you know, people can contextualize and visualize and understand what's going on based on the code reading and the supplemental information you're giving, with keyword being supplemental. Because, you know, as it mentions at the end, well-written comments increase the value of code and increase to the overall understanding of what's going on, right? A good comment system lets you come back to a system 2 years later, and even if, you know, the language has changed, you're on a different version, implementations don't make sense anymore, you can still understand what each chunk is doing, even if the language looks completely new, and work with that to, like, say, bring it to a new language level, or just rewriting it from scratch, because you know everything that's happening there and nothing is an unknown.
Do you think Accelerate does comments well, or do you have like a code base that you've seen that you think does comments particularly well?
Sure. I think we do in some areas. Let me pull up some code. So one that's very good that we tend to comment is the accelerator. Let me take a look at some of our comments. So like here, you know, we talk about, well, if deep speed plugin is none, which is like you're using deep speed and you don't pass it to the accelerator, we just say, hey, we're going to knit from the environmental variables here, which, yes, kind of makes sense if you read that here, but this lets you not have to read this annoying part, which is nice. Or even here, talking about how if we do use the plugin, we need to set this flag to know that we're using accelerate deep speed, which clearly the reason why that's commented there is, okay, well, this tells me for some reason this environmental variable is going to be needed later on. So I guess it's good that we enable that, right? So that's one example of where this comment would be good. And then, you know, we tend to repeat that in a few areas. And then we also use it to sort of block out and segment what different chunks of the code are doing. So, you know, we mentioned there's a bunch of quarks handlers here, and that's what happens. Then we start talking about like, okay, well, here we're going to talk about mixed precision, what self.step is, what the heck all of these are, internal references for training objects. And so we don't like overly comment, but if you're sitting there and reading the code base and what's going on, we contextualize sort of and break up the code into paragraphs almost based on the comment. Is the most common one for the accelerator. And then I think a lot of the comments are now examples. Usually we'll use it for like when we deal with some weird metadata, like this is a constructor, but also a decorator. And so this just explains like when we're using it in a function on the accelerator, this is why we need to do this weird thing. You don't need to know what this weird thing is. You just need to know it happens when the accelerator itself wants to use this decorator on itself. And so these are like a few examples where I found that like we do comments decently okay. Or here's a really, really good one that we tend to do. So if it's a weird feature that we can't really give information about, it's just something that we know about, then we'll contextualize it. So like, what in the world is this? Experimental feature, what it's doing, and link to the source code of what the heck is going on. This is another one we do pretty regularly when it comes to things that we can't explain clear enough in a doc string, or when it's just some weird bug and here's why that exists, right? Sometimes we'll link to accelerate issues themselves as to why this exists. That happens also in transformers quite a lot. And so it adds context to what's going on, even if it doesn't fully explain it, right? Because if we were to talk about this experimental thing, explaining it would be like a paragraph. So instead, we just say, hey, it's experimental. Go read more about it here if you want to know more. That makes sense?
Yes. Yep. Thanks.
Perfect. Yeah, no problem. Any other questions before we end the session today? All right, cool. I will see everyone next week for up through chapter 15. I'll see how far I get. We might do 16 just for the heck of it. And then we'll take a week-long break for Christmas and then pick up after that. So see y'all next week.
That's good. Thanks, Zach.
No problem.
Take care, Jack.